as something fine. So here's the cat. Here's the Schrodinger's cat. And why do we need to care about that? Because this example is the very demonstration of how quantum mechanics work. Instead of determining the stuff in the classical mechanics, anything in the quantum region are undetermined. That means, unlike either alive or dead in the classical world, in the quantum world, anything can be a combination of the fundamental state. Like here, for the cat, it's 50% alive and 50% dead. And that's the power how the quantum computer can exponentially better than the classical computer. That's the origin of this power. Okay, so why do we need to care about the next generation of computer? Because just think about that. If everything, like every electron device, your calculator, your cell phone, your PC, has been replaced by the quantum computer, humans' lives will greatly improve. Okay. So in order to prove that quantum computer is exponentially stronger than the classical one, I need to talk about the classical computer a little bit, and then move to the algorithm and theories about quantum computer. So let's start at the classical computer. The classical computer uses the transistor, and it's basically a switch to represent either 1 or 0. If it's closed, there's circuit, and there's 1. If it's not, it's 0. Okay, and those millions, billions of the transistor can build the logic gate, and finally to build the central processor unit, CPU, and that's the core of nowadays classical computer. So at here, you may have a sense how the computer works. It's basically, you must have two things in hand, 1 and 0. In classical world, that's closed or open. How could we build something let the quantum mechanic in action? 1, 0, closed, open, alive or dead. That's the crucial part of quantum computer. But we really don't want to use cat to build a computer. We can let innocent cat kill. We are physicists, so we would like to use electrons to build our first quantum computer. As a primitive model, we can just think about every electron can take 2 positions, spin up and spin down. It's just like 1 and 0, alive or dead. Although the spin term comes from like the coral, but we don't need to care such much. We just need to know spin up and spin down is the only 2 positions electron can have. This is the fundamental property of them, just like their charge and mass. So how could that to empower the quantum computer? Well, if we only have 1 electron, nothing interesting, because we only can have up and down. However, if we have 2 electrons, there's kind of interplay between the 2 electrons. It's like we can have the all linear combination defined by the quantum mechanics. That is up, 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 down, down, up, down, down, 4 states. And if there are 3, 8 states. And in general, if we have n quantum electrons, if we have n electrons, or more abstract speaking, n quantum bit, that's in power 2n. It's like 2n classical bit in the classical computer. And that's how the quantum computer in action, how the quantum computer exponentially stronger than the classical one. My reference, and thank you.